Now, let's see what we have here. Here we have a problem that if this is a factory and this is the warehouse, we need to find out the shortest path that can take me from the factory to the warehouse. And the way we did that in the past is in a very traditional way, using Excel, mathematics, or anything else. Since the book was written, Apple created the iPhone. And since the book is written, Google created Google Maps. And now we have Apple Maps and Google Maps. If you want to get out of here and you want to go to Baruch, you want to find out what is the shortest path that you can go, correct? So, in the old days, when we didn't have this new technology, this is what we had to do. And we had to go on and find out how you can get out of this point and get into this point, selecting the shortest path. And you can select the shortest path based upon what are the connector points. So from 1, you can go to 6 through points 2, 3, 4, and 5. Through 3 and 4 and 5. This is the distance between the points. You don't have Google Maps, you don't have Apple Maps, you don't have computers. How do you go from 1 to 6? When I was a student, and I had to make that situation, I had to take the maps from AAA and say, okay, I need to get out from Albany and go to New York City. How many routes I have? I identified the routes in the map, and then I was calculating the intermediate points to find out the mileage. AAA for big cities, they was giving me directly the mileage, and I was able to make a choice. If I want to go from here, point 1, to here, point 6, Miss Bellini, you would go to point 3 or point 2. This is the mileage that you have. From 1, you would go to 3 or 2. Which one is the closest point? Miss Bellini. 2, because it's half the distance, right? From 2, you could go to 4, 5, or 3. Which one is closest? 3. Why you would go to 3 through 2 and not directly? Because it's shorter. It's 150 this way, it's 200 this way. From 3 now, you can go back to 1, 2, or you would go forward to 5.
5.
Is it short or long?
Shorter.
And anyway, it's the only option that you have not to return back. From 5, you can go to 4, you can return to 2, or you would proceed to 6.
Proceed to 6.
Therefore, the route that you choose is
From 1 to 2.
this one, this one, this one, and this one. What is the maximum amount of mileage that you have? 100 plus 90 plus 100, 290. This is what the computer does. So the computer doesn't do anything else but specify the shortest path. The first statement has all the possible connections between the points. And then what we have is balancing situation for each one of the points, saying how the points are connected. With one particular difference. Now we need to specify by -1 from where we depart, and by 1 where we arrive. -1. Why -1? Because we need to get out of that point. If we decided that we need to get out of another point, then we need to have different departure time. We get up in the morning. When we get up in the morning, I'm getting up in Long Island, Jessica is getting up in Brooklyn. We have different routes to come to the same destination. As a result, I need to specify what is my origin point, what's Jessica's origin point. Intermediate point 0. Why? Because we don't want to stay there. Final destination 1. What do we want? All the points to be either positive or 0, and then I can solve the problem and I can get the solution to the problem. Miss Bellini said that she goes from point 1 to point 3. The computer agrees with her. The computer says from point 1 we don't go to point 3. But from point 2 we do not return back to point 1. From point 2 we go to point 3. And from point 2 we do not go to 4 or to 5. And from 3 we don't go back to 1 or 2, but from 3 we go to 5. And then from 5 we go to 6. And we stay there. And from 6 we don't go anywhere else. This is how we define the shortest path in a mathematical way. Do we need to be bothered with that today? No. No. Why not? The technology changed. And as the technology changed, I can have Google Maps in my computer, Apple Maps in my iPhone, Google Maps in a different place. So what I want to do, I want to come up here and I would ask Holly to solve the problem. And Holly doesn't know anything about mathematics and she has a math phobia. She needs to find out what is the point that I start, and she needs to find out what is the point that we finish. So we need to go here into the map and find out the shortest path. How do we find out the shortest path? We go here to get directions. If we want to spend more money, we can go on, instead of having an iPhone or a Galaxy phone, we get a UPS and we enter the points that we have there. Automatically we get how we can go. So Holly, down here is 199 Chamber Street. Somewhere up in the Midtown is Baruch College. I want you to find the two places and place them in the map. And the rest of you, I would like you to do it also. And I don't care if you do it with your phone, with your GPS device, or with your computer. I want from 199 Chamber Street to go all the way to Baruch. From here to Baruch. Chamber Street. Chamber Street. What are we doing? And what if I want to write? That's wrong.
Like, you want by car, by walking, or I think go by the bus and train. Yeah, but you didn't specify. How do you want us to get there? Walking, by car?
That's what is. I want to compare the alternatives. I'm waiting for Holly to say Okay, Holly did it. Holly did it. You can stay there so that you'll be able to go on and do it. Let's see what's happening here using current technology. Current technology gives you two options. One gives you the map so you can see it. Mathematica does not give you the map. I don't know what kind of changes Mathematica 9 that was just released is having. They want to incorporate all the mapping into Mathematica 9 or 10, so in the future you will have it there. But now you can't have it. You can have it here. May I have your attention? Two important points. When you go on and you get the direction from here, you have an alternative. And you have an alternative. Are you going to drive or not?
Yes.
If you're going to drive, then you have to tell me when you're going to park here. There is a parking down in this building. And with your BMCC ID, you get a discount for a day. If you go to Baruch, do you know where the parking is?
No.
And do you know how much it's going to cost you?
More than one.
I want you to be specific. And tell me not only that this is the shortest path, that you would go there and you would park in that particular place and this is how much it would cost you. Do you have an alternative?
Yeah.
The alternative is to go up here and take a public transportation.
But if you're taking a cab, you don't need to.
Correct. If you take a cab,
You got money for cab every time you gotta go to class? No, I'm just saying.
you have an alternative. If you take a cab, do you make a choice about the shortest path?
No.
The cab driver makes. And you're better off because if you're in some other countries, the cab driver for a very short distance can take you big route and you would be able to spend a lot of money. I had that experience in Rome. I went from one place to the other and it took me half an hour to go. I paid a lot of money. If I walked, it would be there in 5 minutes. That particular day, the driver was right. They had a demonstration and the roads were closed. I didn't know it. And I had a suitcase with me, otherwise I would go on and walk. So, real life imposes real problems. Real problems require you to face them and see what's happening. Can you walk from up here to down there?
Yes. Yes, it's going to take you a long time.
Can you bike? What is the alternative of the different solutions that you have? I want you to be able to say it and specify it and talk about that in plain English. And I want you to use the most recent technology, and I don't want you to be bothered with how Mathematica solves the problem, because now you have a solution that you have here. The important part is that when you look for larger geographical areas, that they may have specific links, particularly like New York, that tunnels and bridges are important. Today's technology allows you to take another element into consideration. And the other element into consideration is to look what's going on with the traffic. Because every Wednesday morning I have to go and drive to my son for an early class, and I cannot put him in the bus. But every Wednesday morning I need to know what is the traffic of the different major roads that connect my house to his school. Not every Wednesday I use the same route, because not every Wednesday I have the same traffic situation. As a result, what is happening here? It tells you that in that particular point, right now, you have heavy traffic and you will have delays. You may need to go on and have a different solution. It tells you that up here and up here, you have work on the road. As a result, something is happening. It tells you that somewhere there is an accident and the road is closed. What happened in that particular case? You look for the alternative. And this is what I want you to know for that part of the problems, because shortest path codes right now are obsolete the way that the book has it and the way I was teaching it with Mathematica and Excel a few years ago, because now the technology is different. They tell me from Mathematica that in the newest version of Mathematica, they will have direct connection with all that stuff, so you would have it there. So far I haven't said, this is the way I want you to be able to do it. Decisions that you have to make is you pick up a point that is a starting point, you pick up a point that is a destination point. You want to find out the shortest path that connects these 2 points. The shortest path that connects these 2 points is different based upon the mean of transportation and the road conditions. And you've got to be able to look for the alternatives and know what is the shortest path and what is the time that you need to have that particular path. As a result, by looking at different routes, you can have more or less the same mileage, and you can have different timing. What's your objective? You want to minimize timing? Then public transportation cuts that in more than half. You want to have a car here, so you would be able, after everything, to go home and not wait for public transportation. Then you have to pay the price of the extra driving during that part. And this is what I want you to know with respect to the shortest path. Use your GPS devices for having that, and not whatever we can do with Mathematica. Okay? Any questions? Good. How we are doing with respect of time? It's almost 12 o'clock. You want to go?
Let's go have some lunch. Yeah. Pizza and beer.
We have the time. Why don't we use it? You can go. You're free to go. Now, on the 14th, on Friday, I can go through what I want you to do for the final. Since we finish it now, if you want, we can spend that time now and don't have to come on Friday.
Oh, yeah. Okay.
So, final exam.
This is why I wait for all the
Final exam.